Hey there. I'm just going to go through how to quickly make this box plot graph with the data from our class. So the first thing, the mean value is the average. What I would recommend doing is plugging these numbers into your calculator so you can get that average, or if you want to use a shortcut, copy and then just go to a sheet and paste that in there. And since you guys are getting a lot of experience using Google Sheets, paste that in here and then just go through and get your average value. So you can do that by typing in equals average, and it will give you the average of the cells that you are telling it to average. So there's my mean value, 165.3571429. We don't need all those digits, they're not significant, so we're just going to plug in 165 as my mean value for the females. The median value is our middle value in this data set. So we have 14 females that were measured, so we'd have to look at the middle value in this data set, which is not going to be one of the exact numbers in here simply because we have an even number. So what we end up doing is counting 1, 2, 3, 4, 5, 6, 7, and then we have 1, 2, 3, 4, 5, 6, 7 below that. So the numbers in the middle will tell us our median value. So 165 and 168. So if we use those two values and we get the middle value there, it will tell us our mean, which in this case is 167 centimeters. So that's the median height of the females that were measured in this class. The minimum value, since our data was already sorted, is 152. Our maximum value is going to be 178. And then the first quartile is going to be 14 divided by 4, which gives us 3.5. We can round that up to 4 individuals. So these bottom 4 individuals are in the first quartile. So the number is between 161 and 163, which will give me an interquartile of 162 centimeters. And then my third quartile represents 3/4 of the group, which would give me a value exactly right to the, so these top 4 are in that top quartile, so we're going to end up saying 170 as our interquartile. So 169.5 if you went to that decimal spot, but we can just say 170 would give us these 4 in the top quartile, and then everything below 170 is in that third quartile. So the IQR is simply the difference between the third quartile and the first quartile, which gives us a 8 centimeter range for 50% of our population. Now the standard deviation is a little bit more challenging to go about calculating. You can take your mean value, you can subtract every number from the mean, and then you can take the square of that to actually get it. Or the best way to do that is simply plug your number back into that spreadsheet and do the standard deviation formula. So the standard deviation of our data set can be calculated by simply plugging in equal standard deviation of the range that you've selected, and it will give you the return value of 7. So in this case, our standard deviation for our data that we have on the females is 7. Now we want to take this information, we want to put it into a box plot. So we really need 3 values that will help us determine this. One is our median. So for the females, our median value was 167. So I'm going to draw a line at 167, and then my first quartile was 162. So 25% of our population was less than 162, and then the next line is going to be my third quartile, which was at 170. So 170 represents, the lines are a little off on the screen as I'm drawing them, but that's going to be my third quartile or my upper quartile range. So all my values between here and here and here represent my IQR IQR. That's my interquartile range, 50% of the population. So now I can do my whiskers on this graph, and I need my maximum and minimum value for this. So my maximum value is 178, so I'm going to put a dot right there. And I'm going to draw a line to connect that dot. And then my minimum value is 152, which is going to be right about there. And I can draw that whisker, and there's my box plot. So that's how you do it. It gives us a nice idea of the spread or the dispersion of our data. 50% of our data falls within the IQR. 25% of our data falls between 152 and 162. The other part of the population, if we look at the upper quartile, we see that 25% of the population was 170 to 178. So again, it's a small data set, but it allows us to do the box plot for this particular graph. Now you should be able to do it for the males, and you can compare the two data sets to see how they compare, and that will help us give an understanding of how we can use box plots for comparing data sets.